Okay, so some of you wanted me to do this. You don't understand, let me do it for you here. So let me just remind you about what we had so far. So if I have a curve or for the function f of x, and then I have two vertical lines a and b, and I am interested in finding this area is equal to the integral from a to b f of x dx, yes? And then if I have this below the x-axis, then I told you that the integral is not exactly the area minus the integral is the area, okay, if the area is below the x-axis. It's a very simple thing to remember. And I told you that if it goes up and down, then you have to alternate. The positive ones are the ones which a is above, and the negative ones are the one that a is below. For example, let me solve you immediately an example here. So something like this. So example 3 here in my notes. So using the information given on the following figure, determine the exact value of this integral from -2 to 2 f of x dx. So in this picture, you see that the rule of f is not given, and the whole point is not to find the rule of the function, because it takes a long time. But you need to understand what is the meaning of that. So let me just draw this here on the board. So that red one is the function f, but you are supposed to calculate the integral from -2 to 2. Let me put a factor there as well. For example, 5f of x dx. Okay, instead of writing just f of x dx, we can say 5f of x dx. Okay. So it's a very simple problem. I don't think it's a hard question, but you need to have a good understanding about how area relates itself to the notion of an integral. The first thing that you need to understand is what should you do with this 5? Because this is the graph of f, not 5f of 5f. Of course, you can draw the graph of 5f, but that is time consuming. What you need to do is to know that 5, a multiplicative constant, can be pulled out. So this becomes 5 integral from -2 to 2 f of x dx. Okay? And then this integral is related to the area. If you can use the area, find this integral, whatever you find, you multiply it by 5, and that's your answer. So I need to find this area. But then you realize that x equals to -2 is this vertical line. X equals to 2 is this vertical line. So I want to calculate that integral. So which areas are involved? Can you see? Because the areas should be between the curve and the x-axis and these two vertical lines. So there are 3 areas involved. Do you see this one? And you have this one. And you have this. Yes? So if I want to calculate that integral without that 5, I have to consider 3 areas. So if you don't mind, let me call this one area number 1, this one area number 2, and this one area number 3. The first duty that you have is to calculate these areas. So what is this area? This length is how much? This number was -1. So this length is 1 unit. And this length is how much? Yeah, if you see the picture, precise picture, it's 1/2. So then the area number 1 becomes what? Length multiplied. So this is the height. This is the right angle triangle. So you multiply this by that and then divide it by 2. So it becomes 1/4 area units. That is area number 1. Yes? But what is area number 2? Number 2 is a triangle. Yes? So what do? You have to multiply the height by the base and then divide it by 2. But what is the height? The height, if you see the better picture there, is 2 units. Multiplied by the base. How much is the base? This point is 1. This is -1. This is minus 2, but this is minus 1 comma 5. So this length is how much? 2 comma 5. Yes? And then you divide it by 2. Yes? So this is 5 over 2. And then finally, this area is again another triangle. So area number 3 is what? This length multiplied by that length divided by 2. Both of them are 1. So it becomes 1/2. But be careful, two of them are below the x-axis, one of them is above the x-axis. So if I want to calculate the integral from minus 2 to 2 f of x dx, what should I do then? I write minus a1, not a1, because a1 is below the x-axis. And then I write plus a2, because a2 is above the x-axis. And then I write minus a3, because it's below the x-axis. That's it. And I put the numbers there. So it becomes 1 over 4, so it's minus 1 over 4. a2 is 5 over 2, and a3 is minus 1/2. Yes? And then you calculate these numbers. So that is 7 over 4. Don't write area units because this is the integral. You used the notion of area to find an integral. But the question mark is not the integral, it's 5 times the integral. So you just multiply this number by 5, so it is 35 over 4. So it's a typical question that sometimes they give you the area, you are supposed to find an integral. Sometimes you have the integral, you find the area. So you have to know what to do. And the rule is very simple. If the area is below, it comes with a negative sign. If the area is above, it comes with a positive sign. Okay, is that understandable? Okay. So let me see. Okay, so for example, let us solve another, this is a level 3 problem, but let us solve it, okay? In the following figure, determine the exact value of A so that the closed area is, I don't know why I've written B, is 7 over 3 ln of 4 area units. Yes, is the question clear? So you see the picture, the colored region is here. You want to fine-tune the value of A so that this area is exactly 7 over 3 ln of 4. Yeah, this is a complicated question. It's not complicated. If you have listened to me and you have it in memory, it's not hard. But if you have forgotten something, it becomes a little bit hard. This is still not under the title of area between the curves. I'm reviewing what you need to do from the simple formulas. Then I will talk to you about the area between the curves. Okay, so let us try to sketch the graph here. So then what happens, so this is a graph given to me like this, for example. They have given us the function f of x is what? 7 over 3x plus e. E is the Euler number. And they have written from a to e, Euler number. This area, let us call it a, this is given to me to be 7 over 3 ln of what? 4 area units. And the question is that you need to find A. Yes?
It's E to A, not A.
E to A, thank you very much. E to A. Okay? So you need to find this A. Again, if it is an A-level question, it deserves some A points, but still you can write something for it, yes? So how do you do that? Usually in the standard problem, they give you A, they give you B, they give you the function, they ask you to find the area. This is the straightforward questions. But in this question, they have changed the order. The area is already given. This number E is a given number, Euler number. So then you need to find A. So this is exactly this problem engineered in the reversed order. Instead of giving you A and B and asking you to find the area, they have given you the area or asking you to find one of those numbers. But that's essentially the same problem. So what do we do here? What is the first starting point? The first starting point is that this area is equal to what? is equal to the integral, because this area is above the x-axis, so I don't need to put that minus sign, of my function, which is this function, dx. What is the lower limit here? The starting point. What is the upper limit? The final point. And the question mark is on A. Okay, so that is not hard at all. Okay? So what you need to do, for the time being, don't worry about this. Of course, you understand that your problem is to calculate the integral. Okay? To calculate the integral in this course, there's one type of thing you need to keep, remember, and that is what is a primitive function. Okay, this is an A-level question, so I made it from the A-level questions in the book. So you need to know how to find a primitive function for this. Okay, so then I don't know, you have the exam tomorrow, so how many of you remember how can I calculate a primitive function for this? Because this is one of those questions that if you don't remember the trick, the formula sheet is useless. U prime over U, thank you. So if you don't remember that, it is hard. But if you remember the trick is U prime over U, you have these kinds of questions in the book. So you have to know it. When I was teaching, I gave you a lot of examples. So this, you need to familiarize your eyes with this pattern, U prime over U. Because U prime over U is the derivative of ln of U. This is a very famous pattern, a fraction whose numerator is the derivative of the denominator. So this means that a primitive function, if you have forgotten, write it somewhere, a primitive function of U prime over U is what? A primitive function means a function whose derivative is this, and it is on the board. Which function is that whose derivative is this? ln of U. So this is one of those questions that if you don't remember this, then it's hopeless. So you have to remember this somehow. Okay? So, but of course, is it exactly the case here? You see, no. Yes? Because the derivative of the denominator is what? Is 3. But what's the number up there? It's 7. They are not exactly the same, but if you saw that example when I was teaching you in the lesson, you know how to fix it. Okay? So what I do, I copy and paste this left side, 7 over 3. Okay, if you don't want, I'm lazy to write this one, so I continue from here. So this 7, first of all, is not a big problem. So you know that 7 up there can be written as 7 times 1 over 3x plus e, yes? And this is a multiplicative constant. A multiplicative constant can be pulled out from the integral, yes? So this becomes 7, and then I have a 1 over 3x plus e dx. But it didn't solve my problem because the derivative of this is 3, I have 1. But you know how to fix it. How should I fix it? I want to have 3, but I have 1. So what I do, I clean and write it 3, but I am not allowed to change the problem given to me unless I compensate for the change. So it was 1, I wrote it 3, it is not a big problem if I also divide by 3. Yes? Is that right or not? Okay, now everything is in order. If I give this, the role of u in my head to this, this becomes exactly u prime. So it is u prime over u. And the primitive function for u prime over u is ln of u. So I can continue. I copy and paste this 7 over 3 here. And then what should I do? I write ln of u. But what is my u? Is 3x plus e. But you know that you have to run it from where to where? From e to a. Okay, and then I continue. So you know what to do. You split it into 2 parts. You put a for x everywhere. You put e for x everywhere. So it becomes 3e plus another e, which becomes 4e. And then you go back to horizontal line and subtract them. Yes or no? Okay. So now, I mean, up to here, you get most of the points, of course. So what I have, let me write it in front of I. So this is what I have on the left side. And this is what I got for the right side. Yes? And then your duty is to find this A. Okay? So what should I do first? Yes? For E, thank you. Yeah. So what do I do first? I get rid of these bad numbers, yes? So I designed the question in a way that these are cancelled. So you divide everything by 7 over 3 everywhere. So this is gone, that's also gone. So let me write it in front of your eyes once more. Okay. So if there are three A points for this question, up to here you get 2 points, even if you cannot solve it. But it is easy. How should I solve it? There are some formulas in the formula sheet. These things are famous. I don't know, you might haven't studied logarithms very well in the previous courses, but ln of 4e can be written as what? No, not 4 ln of e. It is in the formula sheet, but yes?
ln4
plus ln of e. That's the formula. So this becomes ln of 4 plus ln of e, because there is a formula not for ln directly. ln is a logarithm, and then you have formulas for logarithms in the formula sheet. So the ln of x times y, as any logarithm, it becomes ln of the first one plus ln of the second one. So that's the form. But what is ln of e? This is very famous to know. It's 1. So this is 1 plus ln of 4. Yes? Do you agree? But there is a minus sign here. So this becomes ln of 4 equals to ln of 3a plus e. So minus sign is for the whole package. So minus sign will go for both of them. It becomes minus 1 minus ln of 4. Okay, so I made the problem harder. Now I realize it's not a good way doing it. Okay, so let me do it a little bit different because I have to go backward again. If you don't mind, let me move this to the other side because I want to isolate my A. It's a better way. So it becomes ln of 4e is equal to ln of 3a plus e. Because I want to be able to compare both sides. So that was not wrong, but that is what not very useful. So now I change my strategy, I move it to the other side, okay? And then what happens here, it becomes ln of this multiplied by that is equal to ln of this. Yes? And now ln and ln's are equal. This cannot happen unless this and that are the same. I move this to the other side. It becomes 15e and divide by 3. So the a that I am looking for is 5. Okay. So there, of course, A-level questions are not complicated computationally. You see, the computation was not hard. I tried to explain a lot, so I wrote a lot, but the computation is not heavy. But you know, you should be able to combine different problems from different fields. So this is related to solving a logarithmic equation. You need to understand this and a lot of things. Okay, hopefully you understood what's going on. Okay, now let us go back to the topic I wanted to talk. Some people didn't feel comfortable, but they didn't show up actually for this lesson. Anyway. So, that is the area between the curves. The area between the curves is more or less the same problem, but in the original problem, I have one function involved, but in this new topic, I have two functions involved, yes? And then the good news is that there are not different scenarios. For the exam, you just need to know if I have two functions, it doesn't matter if they are above the x-axis or below the x-axis. Let us say it starts from A and it goes up to B. And let us say this function above is f of x this function below is g of x. This time I am interested in this area, which is limited still between those two vertical lines. Sorry, let me put B here. The vertical lines are still A and B, and the function above is f of x. But instead of having the x-axis, I have another function below. Yes? So then I am interested to find the area between those two vertical lines as before, but now between two functions, not one function and the x-axis. If I want to find this area is integral of the function coming above minus the function coming below, and then d of x. X goes from A to B. Okay. In order to understand why this is true, of course, for the exam, why is not that relevant, but let us try to understand it. Before doing it, if you don't mind, let me draw this one for you. So the area is completely above the x-axis. I don't think you have any problems to understand this area. Yes, this area. This is f function, this is g function. How can I find that area? It's simple, yes? So you say that, okay, I find this bigger area, which I know what to do. So the area of the bigger one is the integral. Try to ignore this in your head. Then it becomes this problem. Do you agree? So then it becomes integral from A to B f of x dx. But of course, this hatched area is not the area that I'm looking for. I have to be able to get rid of this part. But that part is also the same problem, but for which function? For g function. So you write g of x dx from A to B. The area that I am looking for is what in this scenario? Is the bigger hatched area minus this smaller area. Yes? So this one minus that one is the area that I'm looking for. So this becomes the integral from A to B f of x dx minus integral from A to B g of x dx. You can keep it like this, but that is a rule that primitive function for the difference is the difference of primitive functions. So what you can do, you can combine them into one integral, and this is usually the case people do it. Instead of writing two separate integrals, they write it like this. But you might think that, okay, I will be in trouble if this goes below the x-axis or not. Okay, I will not be in trouble. Why? For example, I want to justify this is still valid. So be careful. The only thing that you have to be careful about minus sign or negative signs for these cases. But between the two curves, you don't care which one, if the area goes below or it doesn't. What you have to care is which one is above, which one is below, because it is sensitive. The one coming first is the one above, the one coming second is the one below. So that is sensitive to that. Okay, why it doesn't matter? Because, for example, let us consider this as a rigid object. And I move it upwards as a rigid object. If I move the upward, I will not affect the value of the area. The area will still remain the same. But let us say that I move it upward so that the area completely goes above the x-axis. Of course, my functions will change, but how they will change? Be careful, I am shifting upward. Yes? Yes, every function that I had before will be the same function plus the same constant. Yes? So for example, let us say that this length is 5. I move everything 6 units upward. Then everything will go above the x-axis. So what will happen? That function is not the same function, but it is not hard to find the new function. The new function becomes this function, because that's the shift up along the y-axis. But the good news is that this function also will be shifted by the same amount. So the function is not the old function, but this is also this function. But now, what happens? Can I say that the area uses that formula? Yes, because by shifting 6 units upward, this area is above the x-axis. I can find this area using this difference rule. So then the area that I am looking for, which is not affected and it is the old area, it becomes integral from A to B, this function minus that function by that rule, yes? But then you see what happens. So immediately you realize these 6's are cancelled and I go back to the same formula. So this is the reason, but for the exam it is not important, okay? The people who are interested to know why this is the truth, this is the reason. But for the exam you just need to know that if you have the area between two curves, you need to write the integral of the difference of two functions, which comes first, the one above, which comes second, the one below. That's it. And then if you calculate that integral, it gives you the area. Yes, please.
And it's no different if both the functions are below.
No, it doesn't matter at all. Because I can just analyze this by shifting more, you know.
I was thinking about if it was like sensitive.
No, it's not sensitive. No, because if you understand that, you can see that it's not sensitive. Because if both of them are below, then instead of shifting 6 units, I don't know, shift 100 units. Yes, then everything will go above. And then what will I get? I will get plus 100 minus 100 is 0. Yes, so that's important that if you want to use this formula, it doesn't matter. And by the way, if I told you this before, the reason I didn't do that because the book is in this order. If I gave you this before, you can find these to yourself. Why? Because this can also be viewed as the area between two curves, between two functions, not curves. One of them is the function f of x. What is the other function? Y equals to 0. Yes, because this is the x-axis. X-axis has equation y equals to 0. So what happens? I would write f of x minus 0. Yes? So this can be viewed as f of x, the function above, minus the function below. The function below is y equals to 0. So now I will get that one. But what about this one? The function above is what? The function above is y equal to 0 minus the function below is f of x, integral. And then you see that this minus sign goes out. Yeah, so that's the same. It doesn't matter how you, but if you want for the exam, it is better to have these things in your memory, okay? Okay, now let us try to solve some problems related to this. And let me solve a very simple question first. For example, I give you these two functions. One function is a square root function. I draw it for you. Another function is x squared function. So this becomes this parabola. Yes? And I ask you find the area between two functions. Yes? So two functions are now involved. Okay, it's a very standard problem in this case. Why this is the new topic? Because two functions are involved. And I want to find the area between those. Okay, so what happens here? I need to write integral. So I need to find this point because this is the lowest value of x related to this region, which is 0. And I need to find the highest value of x for this region. The highest value of x is here. It is not hard to find it. I will put it up there. But you first tell me, what should I write here? I have to write the difference of two functions. It is important to see the picture and see which one is above. So which one is coming above? Square root of x. And which is coming below is x squared dx. So this is what you need to write. The only problem is what that is. If that's a grid paper, so you can read it from the grids. But sometimes you don't have the grid paper in the national exam or in an exam. You need to find it yourself. But finding it yourself is also very simple. How should I do that? This point is the intersection between these two curves. So I solve a system. Y is the square root of x. Y is x squared. Okay, it's very simple. I put y is equal and then try to find x. I mean, you can also guess it, but anyway, I raise it to power 2 because I want to get rid of the square root. I move this to the other side. I factor x out. Then either x is 0 or x is 1. X is 0 or is already in front of me, so it is clear that this question mark I didn't know about is 1. Yes? Understandable? Okay, so that is x equals to 0, x equals to 1. So this question mark is now clear. So I have to calculate. And again, This is the important lesson that even before people going to Brussels, we had this. So the most important lesson was the primitive function lesson. Because everything you do it, this is a minor thing. The important thing is to calculate this integral. And to calculate that integral, you just need to know how to find a primitive function. A primitive function like this was not a standard, so you have to know it separately. Yes? Do you remember? There are three things that I told you know separately. A primitive function for this combination. Do you remember what was another one? No, square root of x, you can change it. It's easy. But the other formulas are, what is a primitive function for sine x squared, this combination, or let me say sine box squared, and then cosine box squared. I will talk about that, remind you a little bit. So this combination, that combination, and that combination, you need to know separately. Okay? If you don't know the trick, there is no point. You have to use your memory then, for you to be very creative. Okay? So, these three combinations, I have talked about all of them in my lesson for primitive functions. If you have forgotten, you can review. Okay, but now, these are standard ones. I wouldn't consider this a hard problem. My recording, yes. Okay, so what should I do now? I need to calculate that integral. But you know that this is not in the formula sheet. Yes, this is in the formula sheet, but you know the trick. What should you do? You need to reform it so that you can have it in the table of formula sheet. How should I reform it? You know, it's x to power 1/2 minus x squared dx. Be careful, I am not allowed to eliminate this sign yet because I haven't done primitive function part. I am changing how it looks. So I have to write this there. When I use the table and find the primitive function, then I have to eliminate the integral sign. It's a have to, okay? So, do you remember what should I do? So this becomes equal to. The first one is x to power 1/2. Do you know the rule? 1/2 plus 1 divided by 1. Okay. So it becomes 1 over 1/2 plus 1, x to power 1/2 plus 1. And the next one is simple to do within your head. It becomes 1 over 3x to power 3. Then you have to draw a vertical line in front and write from 0 to 1. If you don't mind, let me calculate this in my head. So it is 3 over 2, 1 over 3 over 2, it becomes 2 over 3. And this is also 3 over 2. Then I see that I can break it into two parts, replace every x with 1, but 1 to any power is 1 itself. So it becomes 1/3, and then put 0, but 0 is very simple. 0, 0, so it is 0. Then I go back to horizontal line, yes? And then of course I write area units because I'm using integral to calculate an area. This is the most standard example if I have two curves involved, yes? I don't know, might be they draw a picture for you. Let me change the problem slightly. So what you do, you have this function, the same function, yes, and this function is also the same function, y is equal to x squared. I don't want this part, so I ignore that. But let me do it like this. So should I, do you mind if I remove this? Yes, so let me remove this, because I want to continue this a little bit more. So let us say it continues up to here. And let us say, do you remember what this point was? 1. But I don't want it. I want you to calculate this area. Okay, I will tell you why. So this is a good exercise. So then I hatch these two areas for you in the exam or in the national exam. And the question will be this. In the following figure, find the total area. Okay, so that's also a simple question, but a little bit harder than the previous one, because now the area has been broken into two parts. Okay, so the functions are involved the same. So it means that you might think that I will write the same thing, okay? But the problem is that you understand that you don't know which one is above, which one is below. Why? Because if you go from here to here, the square root of x is above, x squared is below. But when I go beyond 1, the scenario changes. Now this curve is above, the other curve is below. So you cannot go from 0 to 2 directly. Yes? Because when you go from 0 to 2, the scenario changes. So then it means what to do?
Make one integral for both of them.
Yeah, so you need to find this area and that area separately and add them together. So that's it. So what happens for this area if I call it, so let me don't write a1 and 2. So we already calculated this number before, it is 1. So I need to write from 0 to 1. What should I write first? The curve above is the square root of x minus the curve below is x squared dx. But that is not the whole story. Plus, I have another part which becomes what? Integral of which function minus which function this time? The one above suddenly becomes the other way around. So I have to write x squared first and minus the one below dx. And what are the limits?
1 and 2.
The limits goes from 1 to 2. So I have two integrals to calculate. But don't think that they can be combined to one. No, because the limits are different. So they are not, you cannot combine them. You have to calculate this. Okay, finish it, calculate this, and finish it, and then add them up. Okay, so we already did that part. The answer was what? It was 1/3. So what I need to do is just to do this part now. And that part is also simple, because most of the important part is to find the primitive function. The primitive function doesn't change that much. It changes by minus sign. The first one becomes 1/3 x to the power of 3. The second one becomes a 2/3 x to the power of 3 over 2. And then, of course, I have to run it from 1 to 2. And then I split it into two parts, and I don't want to do it, so you know what to do. Yes, you put 2 there, you put 1 there, subtract them, it becomes a number. Whatever you get and whatever you had, you add them up, you have the total area. Is that clear? Okay. So I will give you one example here. It's a good example. I changed this a little bit from the book, but this is one type of questions that you might also get. So the colored region is the region between the graphs of the functions y equals to sine x and y equals to sine 2x. Determine the area of the colored region. Are the colors clear? Yeah, this part and that part are colored. So I want to find the total area. Make it dark a little bit. Yes. It's the problem from your book, but in your book it was in the grid paper and everything, but this is not in the grid paper, so you should be able to do it. But I want you to understand that this is related to what I talked now, because that is the area between two curves, yes? So you think a little bit, so I erase the board. So it depends a little bit. So which one is sine, which one is sine 2? Sine 2x. You need to understand yourself which one is sine x and which one is sine 2x. I don't think it's hard. Which one is sine x? I don't know which one is that.
The one with the short.
This one?
Yeah.
Is that right? No. Yes, because which one has a sharper period, has a bigger period?
The blue one is sine 2x.
Yeah, because you see, this period, the period of this function is half of the period of that function. Is that right? And if you remember, if I have a function sine bx, the period is pi, is 2 pi divided by this number. So if I have sine 2x, the period becomes 2 pi divided by 2. If I have sine x, it becomes 2 pi over 1. So the period is 2 pi, the period is pi. So which one has the half of the period now? So this one is the faster one, yes? So this one is sine 2x. So that is up to you to understand first. So this one becomes sine x. Understandable for everyone? Yes? Okay. But now I need to know that I have the same trouble there. Because if I want to find this area, which curve is above? Sine 2x is above, sine x is below. But when I pass this threshold, suddenly sine x goes above, sine 2x goes below. So it shows that you cannot calculate from here to here directly. Exactly like that simpler example, you have to break it into two parts. Yes? Another hard part of this problem is you need to find these points. So I need to know this point because I need to break it up to here. And then I also need to know this point. This point is extremely simple if you remember a little bit about trigonometry. So what that point is, yes, let us write pi, yes? So it is pi. Yes, because this is half of the period. The period of sine x is 2 pi, so this is half a period, so it should be pi. Yes? Okay, but it is not possible to guess this by hand, by eyes. Even if it's a grid paper, you have to calculate. Okay, so this problem is a level 3 problem again. So I want to find that one. So how should I do that? Yes? Yes, I have to solve a system. Whenever I want to find the intersection of two graphs, I need to solve a system. The system is y equals to sine x is equal to sine 2x. So this means that sine 2x should be equal to sine x. And of course, I told you that in harder questions, you have to combine other ideas from different chapters. So here, this is an example in the book, by the way. So it is, you see that they have done the same for finding that point. Even though they have done it in the grid paper, but just by your eyes, you cannot check that because that's not a grid point. So here, I want to solve the problem. How do I solve it? It depends how you want to solve, what you remember from chapter 2. Okay? I prefer to say that, okay, sine, you can use double angle formula as the book did, but I don't think it's necessary. If you know this, do you remember? If sine of a box is equal to sine of a circle, what can I say about box and circle? I say that either they are equal, of course, up to a multiple of 2 pi, or they are, if two sines are equal, either they are equal or they differ by pi. So it is pi minus. These are not in the formula sheet, you know. These are the cases. So if two sines are equal, we had this when we were doing trigonometry. Okay, so what happens here? If I give the roll of box to this and circle to this, then I have 2x equals to x plus 2n pi. Yes, which gives me x equals to 2n pi. This is one option. Or 2x is equal to 180 pi minus circle plus 2n pi. Yes, and then I move this to the other side, it becomes 3x equals to pi plus 2n pi, and then finally divide by 3, it becomes pi over 3 plus 2n pi over 3. Yes. How many solutions I get? I get infinitely many. It is clear because if I continue these curves, they will continue intersecting. But you don't need to do that because your interval is from 0 to pi. You don't need all of it. Does this produce something valuable for you? No, because if I put 0, it gives me 0, which I already knew about it. It's good, but I already know about it. If I give 1, it suddenly gives me 2 pi, which is beyond the interval. So it is not useful. So the only useful one is this one. Okay, now if I put negative ones, it is not useful because it goes to negative parts. So I start with 0. When I start with 0, what do I get? Pi over 3. Is pi over 3 acceptable? Yes, that's the culprit. So now I understand that it's pi over 3. And then, of course, if I give 2, what happens? Of course, in the picture, you see that the second one is here. So you don't need to be worried about that. The second one is coming from which one? It should come from somewhere.
It comes from 1 when you put on.
Yes. If you put 1 here, it becomes 2 pi plus pi over 3 plus pi over 3, which is 3 pi over 3, which is pi. So it gives me something I already know. And then it is useless to continue because I will go beyond my interval. So this number that we couldn't guess, so you see that even if you have the grid paper, you cannot guess this exactly. So you have to calculate it. Okay? And then everything hopefully is clear to you. Yes, what is that? So the total area is what? Is two integrals. One for the narrow part, so, but the narrow part is between two functions. Which function is above? This one, which is sine 2x, minus the one below, which is sine x dx. How should I fill it up? How should I fill it? From 0, which is the lowest number x, and up to here, yes, which is pi over 3. Okay, the second one is integral. Can you tell me what should I write here, here, and here? So what should I write here? Yes, because it starts from pi over 3 and goes up to pi. But which one I should write first now? Sine, because sine is above. So I write sine x minus the other one, which is sine 2x. Okay, so that's the hard part. And then, of course, you have to calculate that and that. Don't think that because they are opposite, they are related. No, usually they are not, because the limits are different. If the limits are the same, yes, you can combine them. For example, if I have integral from a to b, so let me write this, for example, for you. I write sine x squared dx plus cosine x squared dx. And I run it from, for example, 0 to pi over 4. And I also run this from 0 to pi over 4. If I give you this in the exam, one extremely hard way is to calculate them separately. Yes? Because I will tell you that this is one of those cases that formula sheet is not that valuable unless you know what to do. But if I give this, in principle, I can give this as an E-level question. Why? Because I don't have to do them separately, because the limits are the same, and I can write that integral into one integral by adding them up, which I cannot do the same here, unfortunately, yes? I cannot combine these two into one integral because the limits are different. If the limits are the same, you can do that. Okay, and then what happens? You see that extremely simple, because what is this one? Is 1. What is a primitive function for 1? X. So what you write, this is just simply x from 0 to pi over 4, which is just pi over 4. Okay, so if the limits are the same, always think about this. They will give you these questions in the national exam. Except though the D part, the very last D part, D2, the calculations are not heavy. Okay, this is a good guide. I mean, if I'm not talking about D2 part, because you know that the format is how. So you have a B part, you have a C part, you have a D1 part, you have a D2 part, yes? B1, B, you answer in the booklet, final answer. C1, you answer on the answer sheet, you write your solutions, okay? D1, you are allowed to have GeoGebra, but only write the final answers again. And D2, you have the answer sheet as well, you calculate using GeoGebra, and you write your solutions as well. So these two are similar without calculator, with calculator. These two are similar without calculator, with calculator. Okay? So except this D2 part, I would say, might be in D2 part, the calculations are lengthy. But before that, I would say that most of the hard questions are not computationally hard. They're conceptually hard. For example, this is a good question in this part. Because if you don't recognize this very simple rule, then you are really in trouble. Yeah? Yes? But if you understand that, it's a matter of seconds to solve it. So this is a very good guide, by the way, for the exam. Okay, now let me just do this and we finish up. So what should I do here? I have to calculate them separately, even though they are very similar. Okay, so I will write this. This is in the formula sheet. So if you see the formula sheet, this is given to you. plus a c. But c is not important when you are calculating these integrals. You just take this one. But what is playing the role of k in this problem? 2. So it becomes minus 1 over 2 cosine 2x. The other one becomes k is 1 in this problem. A minus sign is in the formula. A minus sign is here. So it becomes plus cosine x. And this should go from 0 to pi over 3. The second one, you can do it faster, but you have to be careful. This is swapped, yes? So you write plus. This one comes first, so it becomes negative cosine x. This comes second, so it becomes plus 1 over 2 cosine 2x. And then this time you have to run it between these two. Okay, so then you have to split it into two parts. Put pi over 3 there. And put 0 there. Okay? And then plus, put pi here. Put pi over 3 here. Okay, and then we can do it step by step. This you can find it in the table of values. These are famous angles. You will find them in the table at the very end of the formula sheet. Okay, I have it in my memory. So 2 pi over 3 is 120 degrees, and the cosine is negative 1/2. So cosine is negative 1/2 times negative 1/2. It becomes positive 1 over 4. And then cosine of pi over 3 is also there, but I have it in my memory, it's 1 over 2. If I add them, it becomes 3/4. And cosine of 0 is 1. So 1 minus 1/2. So minus 1/2 plus 1, which becomes 1/2. Yes? And then I have another scenario. So I put the same numbers there. So, but cosine of pi is minus 1, so it becomes 1. Cosine of 2 pi is 1. So it becomes 1/2. The answer becomes 3 over 2. This one, cosine of pi over 3 is 1/2 minus sign, so it's minus 1/2. And the other one, this is 120 degrees, is minus 1/2, so it becomes minus 1 over 4. And if I add them up, it becomes minus 3/4. And then I go horizontally by writing the number above minus the number below, plus the number above minus the number below. But minus, be careful about minus signs. And then you have to calculate this simple thing, yes? So plus 3/4, another 3/4 becomes 3/2. Another 3/2, it becomes 3 minus 1/2. So it becomes 2,5 area units, yes? Okay, might be this is a good question to understand all the details. But the concept is not hard. So if you have two curves, you know what to do, yes? You need to write the function above minus the function below and then calculate the interval. So what I say that in this chapter, the most important thing is to know how to find a primitive function. And we have 2 complete videos about that. And there was one example, if I remember correctly, it was very long, containing 13 examples or something. So that example is very important. So you need to know how to find primitive functions of different functions, because on the other parts, if you write the integral, the only way that you can calculate the integral is finding primitive functions, and the rest of it is just putting the numbers there and subtracting. Yes? Okay, any questions? Yes, is that understandable? Okay, so I will upload this video as well. Hopefully this time we have a audio there, yes.